This video explains how to solve trig equations. Now, to begin with, we're going to start by reading a trig graph because that will explain to you what we're doing when we're solving. So here we have a graph of y equals cos theta, and we're going to use this graph to estimate some values. So firstly, the value of cos theta for theta is equal to 200 degrees. So to do that, we need to locate 200 degrees on our axes. Here is 210 degrees. So 200, we divide it by 3, is approximately there. So we're going to have to go down to our graph and then go across to be able to read it. So we need that value there. That would, let's estimate it as approximately negative 0.9. So part A, cos of 200 degrees is approximately, remember your negative 0.9. Okay, B, it's now saying two values of theta for which cos theta equals 0.7. So now we need to go to 0.7 on our y-axis. And that's going to be approximately there. Remember, we're only approximating. Now you expect two values because remember from our unit circle, if we think about our unit circle, we have our ASTC rule, which means cos theta is positive in our first quadrant and our last quadrant. So 0, 90 degrees, 180 degrees, 270 degrees. We're going to expect a value between 0 and 90 degrees and another one between 270 and 360 degrees. So let's complete this. Need to go down, down. So we were going up in 30s on our x-axis. So we could say that's around 45 degrees. So cos theta equals 0.7. Theta is approximately 45 degrees for the first one. And the second one, that'll be 300, 330, so maybe around 315 degrees. And we're done. So now let's apply that knowledge to solving trigonometric equations. So the key is going to be that ASTC and knowing where ratios are positive. So remember, it's all in the first quadrant, sine in the second, tan in the third, and cos in the fourth. The other thing you have to remember is we're dealing with theta in the first quadrant, 180 minus theta in the second, 180 plus theta in the third, and 360 minus theta in the fourth. So we're going to use that knowledge and know that is our ratio positive or is it negative? Which quadrants are we in? And let's solve it. So I have put that at the top so you can see that summary that we can refer to. Again, remember that for the domain 0 to 360 degrees, each trig ratio is going to be positive in two quadrants, and similarly, each trig ratio is going to be negative in two quadrants. So therefore, when solving a trigonometric equation, we're going to have two solutions. So the first one says cos theta equals a half. Our first step is our reference angle. Now our reference angle is what is theta in our first quadrant. So that would be equal to inverse cos of a half. So just from trigonometry, if we know that cos theta is a half, to find theta, we would do inverse cos of a half. So inverse cos of 0.5 equals 60 degrees from our calculator. We then go, cos theta is a half, so that's positive. So cos theta is positive. So we know we're in our first and fourth quadrants because that's when cos is positive. So our theta is going to equal, in our first quadrant, it is just our reference angle, so 60. And in our fourth quadrant, it's going to be 360 minus our theta, so 360 minus 60. So our theta is 60 degrees, 360 minus 60 is 300 degrees. Now you can go to your calculator and type in those values and check that cos of 60 is a half and cos of 300 is a half. Now in the next one, we've got solve sine theta equals 0.8, again for 0 to 360 degrees. So our reference angle is equal to inverse sine of 0.8. Go to our calculators. Inverse sine of 0.8 is approximately 53.13 degrees to 2 decimal places. Now, sine theta is positive 0.8. So sine theta is positive. So we're looking at when is sine positive in our first and second quadrants. So that means our theta is going to be approximately 53.13 degrees because that's the first quadrant. And in our second quadrant, it's 180 minus theta. So 180 minus 53.13 degrees. So our theta is approximately 53.13 degrees. And then 180 minus that is 126.87 degrees. And again, you can check your calculators to make sure you haven't made a silly mistake. So let's look at some more examples, but I want you to pause the video and have a go at yourself. Okay, for sine theta is negative half, you just have to remember sine is negative, so you're going to be in your third and your fourth quadrants. Okay, so your first step is your reference angle. Now, when doing your reference angle, it's what it is in the first quadrant. So when we do inverse sine, we do positive a half. Okay, so the key here, we always put in the positive value because we want to know what it is in the first quadrant. That's our reference angle. So inverse sine of 0.5 is 30 degrees. So this is equal to 30 degrees. Now, sine theta is negative a half. So this is where the negative comes into play. So sine theta is negative. So we're looking at the third and fourth quadrants. Okay, now remembering from our ASTC, theta in the first, 180 minus theta in the second, 180 plus theta in the third, 360 minus theta in the fourth, and it's ASTC. Okay, so we're looking at our third quadrant. So our theta is going to be 180 plus theta, so 180 plus 30. And in our fourth quadrant, it's 360 minus theta, so 360 minus 30. So our theta is 210 degrees and 330 degrees. Again, check it on your calculator. But the key is to make sure that when you find your reference angle, you always put the positive value there. Pause the video, have a go at the next one yourself. So tan theta is negative 1.4. So my reference angle is going to equal inverse tan of 1.4. Inverse tan of 1.4 on our calculator is approximately 54.46 degrees. Now, tan is negative, so tan theta is negative. So where is tan negative? In our second and our fourth quadrants. So my theta is going to be approximately, in our second quadrant, it's 180 plus theta. It's 180 plus 54.46 degrees. And in my fourth quadrant, it's 360 minus my theta, so minus my 54.46 degrees. So 180 plus 54.46 is approximately 234.46 degrees, and 360 minus 54.46 degrees is approximately 305.54 degrees. Two more. Again, if you haven't yet, pause the video. My reference angle is going to equal inverse sine of 0.9. So inverse sine of 0.9 is equal to approximately 64.16 degrees. We have sine is positive, so sine theta is positive. So that's going to be my first and second quadrant. So my theta in my first quadrant, that's approximately, is my 64.16 degrees, and in my second quadrant it's 180 minus theta. So 180 minus 64.16 degrees. So we've got approximately 64.16 degrees and 115.84 degrees. Again, remember you can plug these into your calculator and check. Now the next one, we have a 5 out the front. We need this ratio to be on its own. So the first thing I'm going to do is divide both sides by 5. So I end up with cos theta is negative 4 over 5. So cos theta is equal to negative 0.8 if you want to convert it to a decimal. Don't convert it to a decimal if it's not exact. Now, my reference angle is going to equal inverse cos of 0.8, the positive. Do not put in the negative. If you put in the negative, your calculator will find the second quadrant answer because that's where cos is negative. Okay, so that's approximately 36.87 degrees. So cos theta is negative. So it's negative in our second and third quadrant. So my theta is approximately equal to, in my second quadrant, 180 minus 36.87 degrees, and in my third quadrant is going to be 180 plus 36.87 degrees. So theta is going to be equal to 180 minus 36.87 is 143.13 degrees, and 180 plus 36.87 is 216.87 degrees.